before we start parsing our request in the try from function, let's actually paste an example HTTP request here on top so we have a reference about what we are going to parse. So here I have an example HTTP request. It is a GET request to the /search path with some query parameters, and it's using HTTP 1.1. All right, so the first thing I want to do before we actually start parsing the request is change the error type here, because currently we are using a simple string, but we will have different kinds of errors generated from our code, and it would be nice to represent them in a better way. So to represent different types of errors, we can use an enum. Let's create an enum, which we will call a parse error, and this will represent our different kinds of parsing errors that we might encounter while going through the HTTP request. Let's think about the errors that we might have. We need an invalid request error, which will be our general case, just broken request kind of error. We also need an invalid encoding error for the cases when the request is not UTF-8 encoded. So we need invalid encoding. We will only be supporting HTTP 1.1, so we need an invalid protocol error for the cases where the request had a different HTTP version. Oops, and the P has to be capital. And we will also need an invalid method error, because as we know, there is a finite set of HTTP methods. So if we receive a method that is not in this set, we will raise this type of error. Now, to make our error more idiomatic, we have to implement a trait from the standard library called error. First, we have to bring this trait into our scope, so we can say use std error and then the error trait. And now we can just implement error for our parse error, and we'll leave an empty body here. It is not necessary to implement the error trait for our custom error. We can stick it into a result like that, but by implementing the error trait, it will force us to meet some basic expectations for error types. If we look at the definition for error, we encounter a new syntax here at the definition. The name is followed by a colon and then a list of types. So these are actually other traits from the standard library, and with the plus sign we can list as many as we would like. What this means is that the error trait can only be implemented for types that already implement debug and the display trait. All right, so this syntax pretty much means that we cannot implement error on something that does not already implement the set of traits that we list after the colon. And if we come back to our request, we can see that the compiler error that we get here states exactly the same. Parse error does not implement display, and then it complains about that, and also parse error does not implement debug. Let's talk about the display and the debug traits now. The display trait is used when we are formatting a string, for example, in println. So here, when we are using this syntax to substitute it with some data that we pass to the println macro, whatever we pass as a parameter has to implement the display trait. Here we're passing a string, and the string struct implements the display trait, so this is why we can use it for formatting strings in such a way. There is another formatter that we can use here. So if we specify a colon inside of the curly brackets, then we can choose the formatter that we want to use. So colon question mark would mean that we want to use the debug formatter. If we type the code like this will actually invoke the implementation of the debug trait and not the implementation of the display trait. This can be useful in many cases where we want to log to our developer console the debug data from some type, but we can use the display implementation to actually print something that's user facing. In our case, we don't need the debug here. And if we come back to the request, let's first start with the display trait. First thing, we have to pull the trait into our scope. So we can say use std. It's in the FMT. FMT stands for format. So it's in the FMT module. And then here we'll find display. All right. And now if we come down here, we can say that we want to implement display for parse error. All right. If we look at the display implementation, we can copy the signature of the function that it expects us to define. So we can copy that, and we can come here and paste the function. So one thing to notice here is that it is not specifying any generic types to the result. The reason for this is that this is not the normal result that we are using, but it is a special type alias for the format result that actually points to the actual result with some hard-coded error type and value that it will yield on success. So we actually have to import the result from the FMT crate, but now we already have a result in our scope because we know that the result is imported in every scope. The thing that we can do here is we can alias this type using the S keyword, and we can actually call it FMT result. So now in this file, if we use the FMT result, it will actually resolve to the this result type from the format module. So we can change this with FMT result. And we also have to import the formatter here. So we can say use std fmt formatter. Okay, now it is only complaining because we are actually not returning anything from our function. A cool thing that we can do here, when we are importing multiple values from the same module, we can actually use curly brackets after the module. And then in these curly brackets, we can write a comma separated list with all the types that we want to import. So here, if we put the display and the formatter, now we can delete these two. And now on a single line, we are importing these three types from the FMT module. It just saves up some real estate. Okay, let's see how would we implement this function. To implement a format function for the display macro, we have to generate the string that we would want to output, and we have to write it to the formatter here. So to write to the formatter, we can use the write macro, and the write macro takes the formatter as the first parameter, then a string that can contain anything that we would like. It also implements the formatting syntax from println. So for example, in our display and debug implementations, we would want to output the same string in both cases. We will want to have the same implementation. So let's imagine that we will have a function on our parse error type that will be called message. So we can just write this simple format string, and now here we can just call self message, and this will call the message method from the parse error that we have not implemented yet, and it will fill it in this string. Now let's implement this message on the parse error. So here, if we just create a normal implementation block for our parse error, and in it we want a private method that's called message, and it will take a reference to self, and it will output a string. So because self here is an enum, we can just match on self. And in here, we would want to match on all of the variants and then generate some string for each one. So to do that, we will use some Vim macro magic. So we copy all the variants, we paste them here. Now I will record a new Vim macro. So first I want to copy the word, jump to the end, put a quote, jump to the beginning, put a quote, jump to the D, insert a space, jump to the beginning, insert the arrow, jump to the beginning again, prefix the variant with self, and then paste the variant. All right, so this should be our macro. Let's see if it actually worked. Yeah, okay, beautiful. It probably took me more time to record the Vim macro than it would have taken me to actually write all of this manually, but this way it is much cooler at least. One thing to note here is that when we have a match arm like this, which is just short without a scope, the value here is automatically returned from the match. So right now our match expression just returns all of these strings. And if we want, we can actually assign a variable to it. But because this is the last expression in the function body, its return value is automatically returned from the function. So right now, like the string that we match on will be returned by the function automatically. Now let's look at the debug trait. The debug trait will have the exact same signature as the display trait, so we can just copy our implementation of the display trait and just change the name with debug. We also have to import debug into our scope. So if we come down here, now we have an implementation of debug and an implementation of display. Let's actually move these traits under the implementation block for our trait itself. And we can add a new line here to make it pretty. All right, so we have our custom error type. It has one private method that will convert it to a string. It will give us the message for this error. And then we have implemented display and debug on it and the error trait from the standard library. Now the only thing left to do is actually change the error type here from string to parse error. And we would also need to expose our parse error in our mode.rs. So here we can say pubuse request parse error. So now this error type will be usable from outside of the request because we've also defined it as public.